Before we get started on today's lesson, I want to take a look at this warm-up. So we want to write the equation of the tangent line to the graph of y equals x squared at the point 1, 1. So we know that this is a parabola, of course, and it goes through the point 1, 1, and we want to know the equation of this tangent line. That was a terrible picture, but you get the idea. So first we need to find the slope of that tangent line, and of course slope is going to come from the derivative. So the derivative is 2x, and we want to evaluate the slope at the point 1, 1, so we're going to plug in 1. So we find out our slope is 2. And now to write the equation of the line, we're just going to use point slope form. So y minus y equals 2, x minus 1. And that's the equation of this line here. And then we can just leave it in point slope form. That's fine. So let's take a look at those on Desmos, something a lot better than my terrible pictures. So here is the parabola and the point, and I already graphed that. So this is the function and the tangent line. And what I want to do is I want to take a close look right here at that point. Notice that as you get really close to that point, 1, 1, the function and the line are really close together, okay? Those two things are very, very close together. Now, as you get further away, clearly, there's a big difference between those two. But if you're close to that point, the y values on the function are really close to the y values on the line. Now, what we're going to do is kind of utilize that. So let me just get some blank space to write. So if we have just any function, doesn't really matter what it looks like. Okay, so let's just say it looks like this, and we have a point here. I'm going to call this point C, that's the x value, C, and then the y value is f of c, okay? And if I want to write the equation of the tangent line through that, I would need the derivative. So whatever this function is, we'll just call it f of x. I would take the derivative of it, and then I would plug in that point C. Okay, so the slope would be the derivative at the point C. And I can write the equation of the tangent line because now I know its slope, so we'll just put it in point slope form. So y minus y, so the y value is f of c, equals the slope, which is the derivative at c, and then x minus x, and our x coordinate is c. Okay, so this is the tangent line. That's the equation of this tangent line that goes through that point. Okay, so that's what we're going to start with on our notes. I just wanted you to see where that came from because we've done that before. So what we're talking about today is called differentials. So what I just did for you for a function f that's differential at a point c, if you want the tangent line at c f of c, that's the line we just did. So y minus f of c equals the derivative at c times x minus c. This is the point slope form. Sorry, we don't need that. Okay. I don't know what just happened. There we go. And then we can also solve that for y right here. I just added f of c to both sides. So you get f of c plus the derivative at c times x minus c. So we call that the tangent line approximation. And it's also called the linear approximation of f at c. Okay, so it's just the equation of the tangent line. And if we zoom in really close, if we restrict to values that are close to c, we can use the linear function to approximate the function. So on that thing that I had drawn before, let's say we didn't actually know what this function was. We could use the tangent line to approximate values as long as we're close to that point. Okay, so let me show you some of this in practice. I'll get rid of some of these scribbles we don't really need. So we want to find the tangent line approximation of the function 1 plus sine x at the point 0, 1. So we're going to find the tangent line through that point, and then we're going to use a table to compare some values. So the first thing we want to do is find the derivative. So the derivative of 1 is just 0, and the derivative of sine is cosine. And then our slope is going to be when we plug in 0. So cosine of 0 is 1. And then our tangent line is going to be y minus y equals our slope, x minus 0. And I'm going to go ahead and solve that just since that's so basic. So the tangent line approximation is y equals x plus 1. Okay, so here in this table, I have the function. Remember, that's the original function we started with. And then here's the tangent line. Okay, so what we're going to do is we're going to plug in values for x. So first, I'm going to plug into the actual function, okay, f of x. So not this one. I'm going to plug into 1 plus sine x, and I'm just going to use a calculator. So if I plug in negative 0.5, I get 0.5206. If I plug in negative 0.1, I get 0.9002. If I plug in negative 0.09, just putting that in the calculator, it's 0.9900. If I plug in 0, I get 1. And then 0.01, I get 1.01 and 1.0988. And then 1.479. And again, just use your calculator, plug it in. All right, now we're going to plug in those same values into the tangent line, okay, this one. And when we do that, we get 0.5, 0.9, 0.99, 1, 1.01, 1.1, and 1.5. So what I want you to notice is that, remember, we're at this 0.01. As we're close to that 0.0, the y values are the same. And notice if you're just a tenth away in either direction, the y values are basically the same. Sorry, that was 100th. Now, when you get a tenth away, the y values are pretty close. They start to differ a little bit more. And the further we get away from that point, the more our y values are going to differ. But as long as we're close to the 0.0, our tangent line and our function are going to have very, very similar values. So we can use this tangent line to approximate values. Now, we wouldn't want to do that for points that are far away from 0, like you wouldn't want to do that for the number 8, because that's way too far away. But as long as we're close to 0, this will work. And let me show you this on Desmos. We'll get rid of these. Okay, so this is our function, sine 1 plus sine x, and we were looking really close to that point. We wrote the equation of the tangent line, which is that. And like I said, as long as we're close to that 0.01, our y values are really close together, okay? Now, once we start getting a little further away, once we got like to 0.5, now we had a little bit more of a discrepancy between those two y values. But as long as we're close to this point, the y values are going to be super close between the tangent line and the function. So we'll see how we can apply that in the next video.